Hi guys, in this video we are going to learn how to solve an exponential equation with different bases. If you look at the first example given on the board, we are given that 7 into the bracket of 3 raised to the power of x is equal to 350, and the second example is 2 to the power of x is equal to 3 to the power of x plus 1. So if you look at these two examples given, the first example we call it one exponential part because the x we are looking for is in one part of the equation. While this one we have 350, there is no x here. But if you look at the second example, 2 to power x, 3 to power x, we have x in both the left and the right hand side of the equation. So you have to watch this video to the end because this is one exponential part, but in the second example, this is two exponential parts. So we're going to apply different method. So to solve for the value of x from here, the first thing we need to do, as you can see, this 7 is multiplied 3 to the power of x. So we need to isolate this 7 by divide both sides by 7. So we divide the left hand side by 7, then the right hand side by 7. So this 7 is going to delete this 7. We are left with what? 3 to the power of x, which is equal to 350 divided by 7 is going to give us 50. So we call this exponential equation with different bases because this is base 3 and here is 50. And if you look at this equation, there is no way we can make the base to be the same. 3 and 50, think of it. Can you make the base to be the same? No. So we apply logarithm. So, but in this case, since it's one exponential part, we are going to apply logarithm of both sides to the base of 3 because this 3 has an exponent x. So we take the logarithm of 3 to the power of x to the base of 3 because x is raised to 3 here. But in this case that we have x in both sides, we need to be fair here. So we can, so you need to watch this video to the end when we reach example 2. So this is going to be equal to, then we take the log of 50 to the base of 3. So we just take the log of both sides to base 3. So now recall that when we have a log of a number to the power, so the power can come back here to multiply the log. This is one of the properties of logarithm. So here we have x log 3 to the base of 3. So this power come back to multiply log 3 to base 3. So which is equal to log of 50 to the base of 3. Recall that a logarithmic of a number to its base is the same as 1. When the number and the base are the same, is the same as 1. So therefore, the whole of this quantity is 1. 1 multiplied by x is going to give us x, which is equal to log of 50 to the base of 3. So, and here is the value of x from this exponential equation. So now let's go to the second example, which has what? Two exponential parts. We have exponent here and exponent, and we're looking for the value of x. So what do we do? So we are going to take the log to base 10 because in this case we need to be fair. You can't take the log to base 2 and ignore log to base 3. And there's no way we can take the log to base 2 and base 3 at the same time. So we take the log to base 10 of both sides. And remember, when you see log in mathematics, it means when you see log without any base, it means to base 10. So we take log of 2 to the power of x, which is log to base 10, which is equal to log of 3 to the power of x plus 1. So recall that this power is going to come back to multiply the log like the way we did here. So this is going to be what? X log 2, which is equal to, also this power is going to come back. We have x plus 1, then log 3. So what are we going to do next? So we're going to distribute this log 3 into this bracket in order to eliminate the brackets. So we're going to have what? X. So let me draw a line. So we're going to have x log 2, which is equal to x multiplied by log 3. We're going to have x log 3 plus 1 multiplied by log 3 is going to give us log 3. So what do we do next? Here we have x log 2, and in the other side we have x log 3. So we can bring all the term with x together. So we have x log 2, and when this cross to the other side become negative x log 3, which is equal to log 3 in the other side. So what do we do next? Look at the left hand side. We have x log 3, sorry, x log 2, x log 3. So x is common here. So we factor out x. So we open bracket. Here remain only log 2 because x is outside already. minus x is outside, so here we have only log 3, which is equal to log 3. So what is the next thing we're going to do? As you can see in the left hand side, we have x is multiply this bracket. So, and remember, we're looking for the value of x, so we can divide both sides by the coefficient of x, which is the whole of this bracket. So we divide the left hand side by log 2 minus log 3. Then also the right hand side by what? Log 2 minus log 3. So that the whole of this is going to cancel this. We are left with x, which is equal to log 3 over log 2 minus log 3. And here is the value of x from this exponential equation. Thank you for watching, and please follow us for more videos like this. Thanks.